I welcome you all for this artificial intelligence and petroleum engineering session. We are going to discuss about PCA, Principal Component Analysis. So, first of all, we need to understand this is an algorithm on how it is going to help us in petroleum engineering. So, we have different dimensionality data are available. Complexity uh, becomes more when dimensions increases. So dimensions can be of different ways. Like we imagine when it comes to reservoir, like porosity is a dimension, permeability is a dimension, capillary pressure, like that. You can go on talking about different properties as dimensions. So when it comes to AI, if you have more and more dimensions, then understanding of the data will become more difficult. So we have a technique to reduce the complexity of dimensionality, like you can reduce it. So how best we can able to reduce to understand the complexity of dimensions actually. So the data interpretation will become easier when you reduce the dimensionality. For that we are going to use principal component analysis. So what is the objective of this technique? Like what actually we are going to do with principal component analysis? You can see over here, consider the table with two dimensions with well 1, well 2, and we are going to transform to one dimension. Like you can see, two dimensionalities when you say that as well 1 and well 2. So you have different values for well 1, gamma ray log, resistivity log, porosity logs, and saturation logs. So don't worry about the data. So this data represents a reference data for all the parameters that I'm mentioning. So imagine if well1 is a dimension, well2 is another dimension. So representation of this data in between two dimensions will give you some idea. Like, you will be getting some insight. But two dimensions fine. What about like five dimensions, six dimensions, even more than that? So on what way we can able to reduce that dimensions? Like in place of well one, well two, we will make one middle reference plane, and we will name a plane value to that, and we will try to find out four values. So you are reducing that complexity, like you are finding out a reference in between the dimensions. Then we are trying to estimate the distance between these points from the reference plane. So this is what principal component analysis is all about, to reduce the dimensions. And you are going to construct a hyperplane, so which will fall in between the points, so that we can able to distinguish certain points in between them with reference to your hyperplane. How we are going to start working on this? So first, there are five steps are there. First step is to find out means for all variables. So arithmetic mean of these variables has to be defined. Second thing is to construct covariance matrix. So you need, with the help of mean, you need to construct covariance matrix. After that, estimate eigenvalues for covariance matrix. So after finding out these two things, you have to estimate eigenvalues. So you have to, after estimating eigenvalues, you have to estimate eigenvectors. From that eigenvectors, we are going to construct a hyperplane. So we will be seeing step by step. It will be understood in a proper way. So we will go slowly with step 1 to step 5. So step 1. So this is the arithmetic mean x1m. We have given name, like 1 represents your well 1 value. So x is your data, and m represents the mean. So x1m, it is the first values median. So 100 plus 50 plus 12 plus 0.2 by 4. So that value you will be getting here, 40.5. In the same way, x2m represents these four data's mean will be 41.5. So this is your first step. So let us go and construct second step. So you have x1m as 40.5, x2m as 41.5. For constructing covariance, you need to include covariance matrix as x1 x1. So x1 is all the points which belong to well 1. So x2 means all the points which belong to well 2. So to construct covariance point, you're going to use this formula: covariance of x1 x1, covariance of x1 x2, covariance of x2 x1, covariance of x2 x2. So the formula for covariance of x1 is equal to 1 by n minus 1. N is the number of points, means 1 by 4 minus 1. So n represents the number of points. Summation of k is equal to 1 to n. So 1 to n. 1 to 4 x 1k minus x1m. So x1m is nothing but your I'm going to just show this. X1m is this, and x1k represents this value. So 1k into, again, why? Because x1 x1, so these both will be same. So again this value to be this and this value to be this. So in that way we need to distinguish the difference. So you can see, uh, when you are elaborating, when you are opening this equation, so the first value 100 minus your x1m, and the second value will be also 100. Why? Because this is x1k minus x1m into x1k minus x1m. So this is also 100, and this is also your median value. So when it comes to the second option, you can see 100, then the next one is 50. 100 50. So 50 is here, 50 is here, then after that 12. 12 is here, 12 is here. Then after that, point 2. So point 2 is here and point 2 is here. So you need to put all the values out there. And finally, after summation value, you will be getting 2355. Okay, so this is the answer for covariance x1 x1. So the same way you have to do for x1 x2. So here you can see the formula changes. 1k is there, here 2k is there, since it is x2. At the same time, the mean also changes: x1m, x2m. So x1m is 40.5, x2m is 41.5. So the first value will be x1 and the second value will be x2. So that is 110 and 100. In the same way, means also will be adjusted accordingly. The first value will be x1m, second one value will be x2m. Like that, you have to plug all the details over here with these values and mean values. Then finally, for x12, you will be getting 2215. Like that, x21 2255, and x covariance of x2 x2. So this is what the value for x2 x1, and after that x2 x1. The way how we have done earlier, the same way we have to do it here. After getting all these values, you have to form a vector like S2355, 2215, 22. So these are all values representing your vector, like matrix covariance vector x1 x1, x1 x2, x2 x1, x2 x2. So this is your vector. So your second step was completed. Constructing covariance matrix was completed. Then let us go for estimate eigenvalues for covariance vector. So if you want to estimate eigenvalues, what is the formula? Determinant of S minus lambda I is equal to 0. So what is S? That is your covariance vector that we have defined right now. And lambda is a constant, and I represents unit vector, that is 1001. So lambda into 1001 will give you lambda 0 0 lambda. So that value we have to put, and you have to put the value of S value over here. So determinant of S. So if you know the value of det value of this, you can you can use that one. But before that, so you can see S minus lambda I. So S minus lambda I. It is all in full one bracket. So lambda 0 0 lambda will be added to this equation. So you will be getting 2355 minus lambda, and 2215 minus 0 will be 2215, and 2213 minus 0 will be 2213. Again lambda will be here. So 2449 minus lambda. Minus is here, so minus lambda. So determinant AC minus BD. So when you do AC minus BD, you will be getting lambda square minus 4804 lambda plus 8555600. So this is the equation finally you will be getting. So when you are estimating eigenvalues, since it is having a square root over here, so square on the equation, so you will be getting two answers for lambda. So you have to use this formula, minus b plus or minus root over b square minus 4ac by 2a. So a lambda square plus b lambda plus c. So a is equal to 1, b is equal to minus 4804 and c is equal to 8555600. So if you put that value over here, you will be getting with the plus one value, with the minus another value. Out of these two values, you are supposed to select the highest one. So lambda 1, which is having the highest value, 4620, that is your eigenvalue. So 4620, which is the highest, largest value, that will be considered as your eigenvalue. So once you got eigenvalues, then the next step is to estimate eigenvectors. So this is your fourth step. Okay, so before the last step, you need to, once you get the eigenvalues, you have to go and estimate eigenvectors. If you have to estimate eigenvectors, you need to use the formula S minus lambda I into U is equal to 0 vector, zeroth vector. So 0 and 0 will be here. So S minus lambda I into U. What is U? U1, U2. These are components. Actually, these are principal components. So U1 and U2, we are going to cross multiply that with your S minus lambda I. So already we defined this earlier step, like in step 3. So this is the S minus lambda I value. So 2355 minus lambda, 2215, 2213, 2449 minus lambda. So this into U1 plus this into U2. So you can see here when you are putting the values, 2355 minus lambda into U1. So this is the value plus 2215 into U2 is equal to your zeroth vector, which is equal to 0. In the same way, 2213 into U1 and 2449 minus lambda into U2. So this is the value you will be getting 0. Okay. So out of these two values, you can select any one, either first one or second one. For time being, let us select the first value. So select the equation which is your first value. 2335 minus lambda u1 plus 2215 into u2 is equal to 0. So once you got this value from this equation, you can move your LHS 2215 U2 to RHS and it becomes minus 2215 into U2. So U1 by minus, like you can keep minus on this side. So lambda minus 2335 will be there. So we can convert this to this equation. So U2 by lambda minus 2335 and U1 by 2215 is equal to, generally the value, once you get this value, you will be getting a constant term. Let us make that constant value as t. A simple value, simply give that exponent as t. T may have any constant value. At a particular case, if t becomes 1, then what will happen? So u1 will be is equal to 2215 into t, and u2 will become lambda minus 233 into t. If t becomes 1, u1 will become 2215. So, and u2 will become lambda minus 2335. What is lambda? The highest value, which is 4620. So you are supposed to put that value here. So you can put that value in the principal component vector. So where the lambda value is 4620. So after putting this value, you got two principal component values, the 2215, 2285. So this is your fourth step. So you have estimated uh, component vectors, which is equal to 2215, 2285. Then convert this eigenvectors and find unit eigenvectors. So you have estimated up to now vectors, component vectors, which are eigenvectors. So That one you have to convert into eigenvectors, unit eigenvectors, not eigenvectors, it is unit eigenvectors. So unit value will be u1 by distance of u, at the same time u2 by distance of u. So what is the distance? Root over u1 square plus u2 square. So this is your distance value. So root over u1 square is 2215 square plus 2285 square. So that value you have to subdivide with u1 and u2. You got the values as 0.69 and 0.701. So this is actually your first principal component vector. So if you know this value, right now actually you got the axis value of new component, that is principal component 0.69, 0.71. So this is how we are going to use that value. This you can see that principal component value is 0.69, 0.71, somewhere around here. So how this came actually, how this total concept came. So you can see there are 4 points, one, two, three, four. Forget the middle one, just leave it. First one, and like if you put these four values in two-dimensional axis, you will be getting 1, 2, 3, 4. You can see 100, 110. So 100 and here 110. Like that way 50, 45, 12, 11, 0.2, 0.25. So those values alone were kept over here. First of all, first step is that. Second step is, you know where is the midpoint. So midpoint representing 40.5, 41.5. So take 40.5 on x-axis and 41.5 on y-axis. So consider this point where your two midpoints are there as your new axis. So this is your old axis and this is your new axis where exactly your median points are there. You draw a y-axis and x-axis line, and from there try to estimate 0.69 and 0.71. So this is x and this is y-axis. So 0.69 from 0. So right now your 0 value is here. So 0.69 from 0 will be little bit like this, somewhere around 0.69 here. And 0.71, look at which is on y-axis, you have to move towards positive side on y-axis. So this could be the value of your component vector value. So you have located, you can see a yellow color dot is there, which is representing your eigenvector values. So that is your 0.69, 0.71. So you got it over up to here. Then from here what you have to do is, you need to draw a line which is touching towards your axis and extend it towards both sides. So you can extend it down as well as extend it towards top side. So this is your hyperplane which you are watching on yellow color line. So that is actually your hyperplane. So you can see it is separating these 2 points and these 2 points. From this hyperplane, this point is having longer distance and this one is having closer distance and this one is also having somewhat closer distance. So in place of representing in two axes, you can just draw one axis. Imagine if this is your x-axis, the distance from these points towards your x-axis will be in one dimension. So rather than representing in x and y, you can just put one hyperplane in between and you can just make this two dimensions into one dimension. So this is what we name it as principal component analysis. So after this, let us go for the next topic, Navy bias. So this is another algorithm. So on what basis Navy bias will be helping us to understand. So this is earlier also during candidate elimination, the same example I took. So enjoy sport or play tennis. This is a common example mostly we will be seeing. So in artificial intelligence, this is the question which was commonly asked in most of the exams. So I'm just showing you the example of that. So you have different, this data is given to be supervised data. You can see that we are having the outcomes of it. So no, no, yes, yes means you know the outcome. Whether that means outcome will be either yes or no. So you have that values. You have two uh, bias are there here. One is no, another one is yes. So this is your outcome. And we have different constraints like outlook, temperature, humidity, wind, and we have different attributes to that. Sunny, overcast, rain. Like you have three types of attributes for outlook: temperature, hot, mild, cool. So here also we have three attributes, three different attributes. Humidity, high, normal. So we have only two attributes. We don't have any other value. Then when it comes to wind, weak, strong, and no other value. So you have two types of attributes here. So humidity, wind, two attributes, outlook and temperature, three attributes. So if your machine is learned with this data, it will tell you, if you give a case study which falls in this data, then it can, if the combination is not there in this data, then you can able to estimate whether he is ready to play tennis or not. So on what basis it will be contexted to petroleum engineering, I will be telling you. So you may have different petroleum parameters over here. So the petroleum parameters are all heterogeneous: porosity, permeability, saturation, capillary pressure, like that you may have all. And finally, production, yes or no. So whether it will be giving you good production or no. So you may have different combinations. So these different combinations will be studied by your machine. And if you provide any combination of this, like if you see each combination, it will take probability of 3, probability of 3, probability of 2, and it will be very much high in number. But rather, if you give around, like here we have 11 examples. If your machine studies about this, then it will try to prioritize which attribute corresponding to that particular outcome will be given more priorities, and based on that it will provide you whether the outcome will be positive or negative. Okay, this is how the algorithm works. So play 10 is, how many positives are there? 1 2 3 4 5 6. So 5 are there: 1 2 3 4 5 6. So out there are actually total 14 values are there. So we have one, like we are missing some data here, like D11, D12, D13, D14. So the 14 data was supposed to be there, but okay, no problem. This table can be, when I am sending this table to you, I will be sending the updated 14 data. For, you can see we have 14 points, and actually what it shows is, in this table you are having 9 yes and 5 no. So you can see 5 no out of 14, 9 out of 14. So but if you see over here, 1 2 3 4 5 6. So 6 by 11, 1 2 3 4 5 by 11. So this could be the option. Rather than 6, we have to go for 9 here. So nothing, like the table, if it is altered, it will be giving you the exact value. So imagine if you have 9 combinations, sorry, 14 combinations. So 9 is your S and 5 is your no. So this is your probability of yes and probability of no. Then let us discretize different variables like outlook, temperature, humidity, wind. So outlook, temperature, humidity, wind. And outlook is having three uh, attributes, distinct attributes. Temperature is having three more attributes. Humidity is having two attributes, and wind it is having two attributes. So on outlook, sunny, which is yes, that means sunny, sunny 1 2, which are no, and go down 1 no no, here sunny, sunny, so both are yes. Out of yes 2 we have, and how many yeses are there? That are 9. So 2 by 9 is the probability of sunny, which is giving you the attribute as yes for the outcome. In the same way, no, you will be having 3 by 5. Like that, you need to estimate for all the distinct attributes for all the parameters, like all the normal attributes like outlook, temperature, humidity, windy. So for temperature hot, this is the yes by 9 and no by 5. So all the denominators of n side will be 5, and all the denominators for y side will be 9. So 9 plus 5 will be 14. Yes plus no, which is equivalent to 14. So this is how the distinguishment might happen. And First of all, we need to know this. We are going to use these values in the formula. Then imagine if you have a case like your machine have already learned with the data that we have imported to it. So outlook if it is sunny, temperature if it is cool, humidity if it is high, wind is strong. So this combination may not be there in the table. So if that is the case, so what will be your outcome? So for that we are going to use probability of yes, which is related to your v represents your table. So the one which is showing probability of yes towards your table is equal to p of s. So p of s from the table we got 9 by 14. So this is your p of s, and p of sunny which is yes. So you have to go for p of sunny which is yes plus forecast plus rain. You can see P of sunny which is yes. Then it is asking the second one which is cool. So let us see the cool yes term. So the cool is 3 by 9, sunny is 2 by 9. So sunny is P 2 by 9 and cool is 3 by 9. Then comes P of high, humidity high. So which is yes, humidity high 3 by 9. And last one is wind should be strong. Stronger wind 3 by 9. So 3 by 9 into 3 by 9. So you can see 3 by 9 into 3 by 9. Altogether you will be getting a value of 0.0053. In the same way, no. First of all, probability of no will be 5 by 14. Then probability of sunny, which is no. So that will be 3 by 5. And you can see 3 by 5 was supposed to be there, not I think there is a mistake here. So when we are mentioning probability of no, like that is not 9, that is a typo error is there here, so it should be supposed to be 5. Okay, so cool which is no, cool which is no 1 by 5. So we have 1 by 5. And humidity high which is no, that is humidity high which is no, which will be again 1 by 5, 1 by 5, 4 by 5. Humidity high which is no, which is equivalent to 4 by 5. Actually it should be 4 by 5. Yes, 4 by 5 only. Yeah, 4 by 5. And finally wind strong which is no, that the value wind strong which is no will be 3 by 5. So 3 by 5. So after putting all this value, you will be getting an answer of 0.0206. Then the probability of yes will be this value which you got it by total of VNB yes plus VNB no. So 0.053 by 0.0053 plus 0.0206. So that values you have to put it here. So you will be getting a percentage value of 0.205. In the same way 0.0206 which is on no side by again this whole cumulative term. So 0.0053 plus 0.0206. So you got the value will be 0.795. So what does that mean is the chances of getting outcome which is yes is 20.5 percentage. 0.205 can be written as 20.5 percentage. The chances of no will be 79.5 percentage. That means clearly it states that you don't have a chance of getting positive income. So 80% is almost showing that with this combination the outcome likely to be negative. So why? Because it is showing 80 per 79.5%, which represents almost negative side. So this is how the combination of Navy base can help you to understand these techniques. And let us go for we are right now we are talking about the machine has been learning, how it has been learning, and these are all the things we are talking about. Let us try to understand on what basis machine will learn. So training, data set, cross validation. So this is the topic which will help how the machine will learn with the data input that we have given. So first one, let us consider that we have data which is 100%. So you can input out of this 100%, 75 percentage or 70 percentage you can input to learn, like machine will start learning with 70 percentage, and after that you can test machine with other 25 percentage. So in that way it will start understanding the type of data that you have, so that it can try to give you solutions related to this actually. So 75 percentage of your data will be tested, sorry, learned by machine, and remaining 25% will be tested. So you will be getting somewhere around accuracy 85 percentage. It depends on the data. If data is simpler, not much complex, no variabilities, then you can go with this technique. But sometimes what happens is, you can see uh, the uh, whatever you are asking the machine to learn, that may not represents which is in your training, I mean like test data. So test data might be unique compared to your training data. So when, if that is the case, there could be a chance of bias, so results may not come. For that, what you have to do is, you shuffle the data again, you shuffle it. So before going for the second time making machine to learn, shuffle the data. So again you have to go for either 70 or 75 percentage, and remaining 30 percentage will be tested. In that way you can increase a bit amount of accuracy, 87.5. As we know, this is also, not 100% accuracy. Then what we can do next to this? So in place of giving 70-30 or 75-30, let us take one step. Like this is what we say, cross validation. So leave one out. Cross validation means only one point you are leaving it, remaining all points you are giving it for testing. So one point only it is learning. So training will be with one point, remaining all points will be tested. So again, next step, you just make another point and test which was left behind. So which is not that why, because this will take go on. If 100 points means 100 layers it will come, million points means million layers will come. So efficiency of your system will go down. Why? Because continuous iterations for number of times, that will also not be a suitable option. So for that, what we can do, if this is the case, this is also not an accurate one. So maybe for simpler data you can use cross validation, but when it comes to complex data, then it will be a little bit more difficult. So, so cross validation, there is another form came to avoid the such kinds of bias. That is what we say k-fold cross validation. You can see k-fold cross validation. So what is k-fold cross validation? K should be defined, either it is 5 or 6. Imagine you have 100 points. So you can subdivide k by 10 points or even 5 points. Let us try to understand. uh, 5 points could be a suitable option. So if this is 5 points, means you need to subdivide 100 by 5, it will give you 20. So 20 you have to take for the first iteration, 20, and the remaining 80 will be tested. So the trained data will be 20. Second layer, that 20 you have to leave it and concentrate on other 20 in the remaining data. And test data will be repeated for the remaining data values that are available. In the same way, you have to go for the third one. Leave, the last two data values, then go for the new other 20 values and test the data with, uh, you know, other left out points. This also will help you to understand, uh, you know, uh, how, how machine will be learning about data, and it will start providing you inputs. Okay, this is good until, if the data is unique, and if data is not repeated, this is good. So what if the data is more random and repeated? If that is the case, this could not be a suitable option. Why? Because you are training 20, but when you are maybe all the values in 20 could represent no, and all the values in 80 might represent yes. If you are training your data with yes, no, no, and asking to test on yes data, then it will not give you the right effective outcome. For that, what they have gone with advancement is they have gone for stratified cross validation. In this stratified cross validation, the same process will be repeated, but whenever you are training the data, we have to make sure that the proportion of division in between yes and no should be equivalent for the training set as well as for the test set. So test set you are having around uh, yes values are 50 and no values are 50. In the same way, training set also will be having yes values are like related to 50 percentage and no values are related to 15 percentage. So 50 percentage of 20 will be 10 values. So 10 values must be yes and 10 values must be no. In the same way for 80, 40. So 40 yes and 40 no. So you need to continue that demonstration with all other layers we have discussed earlier, so that right now the proportion is similar, then the accuracy will really go. Then another AI algorithm is job scheduling greedy method. So how job scheduling will be done? So you can see we have it's a simple one. It is not that difficult. You have five different jobs which has to be assigned, and which job has to be given priority. So AI will decide that. So how AI will decide which job has to be given first? So each job will consume 1 unit of time. So 1 unit, let us consider that as 1 hour. It can be day, years, or anything, but let us consider to be 1 hour. So J1, J2, J3, J4, J5 is having, they are all about 5 jobs. So each job will produce a profit of 20, like 15, 10, 5, and 1. So you can see these are the profits which were distributed for each job assignments. And the deadlines were given to be 2, 2, 1, 3, 3. So these are units. Like for job 1, you have a deadline up to 2 hours or 2 units. Job 2, 2 units. Job 3, 1 unit. Job 4, 3 units, and job 5, 3 units. So right now you have slots. First slot, second slot, third slot. You have to fit the data in 3 slots, means only 3 jobs can be fitted. So what are the best jobs with this deadlines, how to fit in the slots? So let us try to understand. We have given times for first slot in between 9 to 10, second slot in between 10 to 11, third slot would be 2 to, sorry, 11 to. So right now you need to assign these jobs in these slots. So let us start with the left side. Like you have to always start with the left side. So J1 is the first job which is having a profit unit of 20. So profits were arranged according to their jobs, and it has a deadline of 2 units of time, which can be considered as hours. So that means he can wait until 2 hours. So you can go and check out the slot, that first hour and second hour. So he can finish job in 1 unit of time, but he can wait until 2 hours. So you can give that slot value of J1 in your second slot. Why? Because this is your first slot and second slot. You have 2 slots. Okay, so you can give it of J1 as, you can just plug the value of J1 into the second slot. So you can see how it was fitted, and the profit for that is 20. Then let us go for the second job. So second job also can wait until 2 units of time. So it can fit in either this or this, but this was already filled. So go for the left side of it. Don't go for the right side. Why? Because right side you are having more time. So go for the left side, which is empty. So you can fit your second job in between 0 and 1. Okay, then let us go for the third job. So third job is having profit of 10, but unit is only 1, so it can wait until 1 hour. So you can check out from 0 to 1, the job cannot be performed. Why? Because we don't have a slot which is vacant so that your job 3 can be fitted over here. So then let us go for the next job, which is job 4. So job 4 can wait until 3 units of time. So 9 to 10, 10 to 11, and 11 to 12. So you can use the third slot to fix the data of your third. You can fix your not the third job, the fourth job. You can fix the fourth job, which is having a deadline of 3 units. You can reach up to 3 units, which is empty over here. So you can put the value of J4 at last. So after getting all the values, what is the total profit that we have? So you can see J2 15, J1 11, J2 is 15, J1, sorry, J2 is 15 and J1 is 20. You can see 15 plus 20 plus 5. So which is your last one. Total profit will be considered to be 40 units of profit can be estimated by this job schedule. So waiting hour will be 3 hours. J2, J1, J4 is the order. So remaining jobs can be avoided. So the maximum profit in the submitted time slot, you can fix these 3 jobs. Okay, this is about your job scheduling. I hope it was understood. So job scheduling, cross-validation, training data set, and Navi bias, and principal component analysis. So this is about today's class. Thank you very much, and we will be meeting on our next session.